Okay, I want to make a quick video. The video I made earlier during class didn't work, which is why you haven't seen a post yet. So this is going to show you how to get to the assignment today and how to complete it. Once you log in and you see there's no assignments assigned today, scroll down, go to your science tech book. If you don't see the tech book, I had one or two students that couldn't find it today. Let me know and I'll try to figure out how to get you to the proper assignment. So here is your textbook. We're down in Unit 4. Scroll down to Unit 4, Geology Time and Earth's History, Geologic Time and Earth's History. We're in the concept 4.3, Relative Dating. Just go ahead and click on that. When it loads up, click on the Explore tab. Click on Explore More Resources. And scroll down to the bottom of the page. Scroll all the way down to the bottom of the page, and you'll see the exploration, which is called relative dating. Don't click on the absolute dating one. That's not what we're doing today. Click on the relative dating one. Open it up. You can also go back up to the top and click on the reading to help you answer some of the questions. Let's go ahead and go to the exploration. It's going to open up. It's going to tell you a little bit of instructions on how to do this. Basically, you can take these rock layers and do different things to add to them. So you can deposit some sediments on top, sprinkle some sediments down, and create a new layer. When you get done, you have a new layer right on top. After that, you can add a magma intrusion, which is magma coming up but not reaching the surface. It stays right below, so it's going to cool and harden. We can do a magma extrusion, which is going to be like a small volcano. And then after that, if you need to, you can do some sort of faulting. You can have like a fault open up in between and cause a rift like that. So there's lots of different things you can do here. If you scroll down, they're going to start to ask you questions. So number 1, it asks about a geologic cross-section. A magma intrusion cuts across layers A, B, and C. It does not cut across layer D. What can you infer from this about the relative age of the intrusion? So if A, B, and C were already here, and then the magma got to cut through it, but it didn't cut through D, that tells you that D comes afterwards. That A, B, and C had to be here first. The intrusion comes through, and then D is laid on top of all of them. So think about the sequences, think about cross-cutting relationships, and you can always go back to the book and read through some of these on the second page. So you have the principle of superposition, which talks about the oldest things being on the bottom, the youngest things being on the top. Original horizontality, lateral continuity, and then cross-cutting relationships is going to explain the concept between, your layers have to be there first in order for something to cut through them. If the layers aren't there, the magma is not going to be able to cut through them. It's just going to spill out onto the surface. So you should be able to see that the dike comes in after layer C. Layer C is older. Then you have your intrusion, and then you have layer D layered right on top. Number 2 asks you to examine the 3 underformed ones, and it basically asks you place the layers from oldest to youngest and explain which principle of relative dating you used. So this is going to be superposition. Which one is the oldest? Which one is the youngest? And why? The principle you should use is superposition, and if you know about superposition, it should tell you which one happens to be the youngest and which one happens to be the oldest. So that should help you out a little bit. There's a couple questions you get to skip here. So we've already gone over 1 and 2. Number 3 looks like it should have a picture with it, but there is no picture, so you can't actually answer number 3. So skip number 3. I won't count you out for that. Number 4, 5, and 6. Number 4, there actually is no question. They give you the image, but there's no question along with it, so you don't have to answer number 4. Number 5 and 6 ask you about the picture from number 4. So they're going to ask you which is younger, the fault or the intrusion, and what kind of rock is the intrusion made out of. So one of these cuts through layer D, and one of them does not. And so the one that doesn't cut through layer D probably came first, and then layer D was deposited down over top of it, and then the next thing came and cut through layer D. And so thinking about it that way, you should know which one happened first, the fault or the intrusion. One kind of rock is the intrusion C made of. It's going to be igneous rock. Sedimentary rock can't move like that. Only igneous rock, like a magma, could come up and cut through the layers. 6, using the principles of relative dating, is it possible to tell how many years have passed between the deposition of layers B and E? You cannot do that with this. Relative dating only tells you relatively how old something is. Is it older or is it younger? It doesn't tell you the exact ages or how far apart something is in between. It could be just a couple years in between these layers. It could be 100,000 years or a million. You don't know. So next, they ask about, is this a normal fault or a reverse fault? Just Google normal faults or reverse faults and see which one you have. Basically, in a normal fault, your hanging wall is going to be the one that drops down. Your foot wall will stay up. In a reverse fault, your hanging wall will come up and your foot wall will come down. And if you look at this picture, this layer right here in the foot wall looks like it matches up to this layer right here in the hanging wall. So it looks like the hanging wall side has gone down, which should help you figure out whether it's a reverse fault or a normal fault. And that also should help you figure out what kind of stress it is. Is it tensional stress or is it compressional stress? So make sure you get that one filled in. Why are fossils unlikely to be found in igneous rocks or an igneous intrusion? I think you should be able to figure that one out on your own. You could also do a little bit of research online to help you figure that out. But igneous rocks are a certain type of material, and that doesn't really lend itself to having fossils. So it should be pretty easy to figure out why. Let's see, number 9, use exploration. You can't sketch and label in this assignment, so don't do number 9. You can go up and mess with it and kind of create what they're asking you to do, but you don't have to sketch and label it. Number 10, referring to the cross-section below. So basically, number 10, you need to put these in order. So tell me which layer came first and is the oldest. You're going to go from oldest to youngest. And just give me the letters. Going from the bottom up and then thinking about cross-cutting relationships, what cuts through what. The layers had to be there first before something could cut through them. So try to put them in order using the letters. So if you have any questions, please let me know. Don't answer number 3. Don't answer number 4. You can do 5 and 6. And don't answer number 9. So omit 3, 4, and 9, and that should help you out a little bit. So if you have any questions, please let me know. Send me an email, and I will get back to you. Sorry for the delay on this video, but it was a technical problem that was out of my control. So everybody have a nice day, and make sure you get this assignment completed.